In today's video, we will learn about the non-metallic character. So, the element which have a tendency to gain electron and form negative ions are said to exhibit the non-metallic character, right? That means the element will also be called the non-metals. Thus, non-metals are the electronegative as they tends to form bond by gaining electron, or we can say that by gaining the negative charge on them. For example, oxygen and chlorine are strongly electronegative and non-metallic as their atoms gain 2 electrons in case of oxygen and 1 electron in case of chlorine. Here you can see oxygen by gaining 2 electrons become oxygen 2 negative because this is the stable state of oxygen, that means has 8 electrons in the outermost cell, right? Here chlorine by gaining 1 electron becomes chlorine 1 negative, that means becomes stable by gaining 8 electron in the outermost cell. Now talking about this non-metallic character trend in a period. So as we know, in a period the electronegativity from left to right in a period, right? From left to right the electronegativity increases. That's why the electronegativity with the non-metallic character increase from left to right in a period. That means when we move from first element of a period to the element in the group 17 or in the first period of group 17, right? This is the period. So the non-metallic character increases from left to right in a period, right? You can see here these are some elements in the starting of a period. Then moving along this period the electronegativity increases and the non-metallic character increases also. Here the starter member are metals, then we have metalloids in the middle of the periodic table in a period, and then we have the non-metals that have the highest electronegativity and the non-metallic character, right? Now talking about the trend of non-metallic character in a group. So the non-metallic character in a group, if we move top to bottom of a group, we know that the electronegative character decreases down the group. That's why the non-metallic character also decreases down the group because the atomic size increases, due to which the affinity to lose the electron increases and the electronegativity decreases. Therefore, the tendency to gain electron decreases and therefore the non-metallic character decreases down the group. Here, all the halogens are typically non-metals. Fluorine is most electronegative and has most non-metallic, and iodine the least, right? In fact, iodine crystal shows some metallic lustrous property also. Now talking about the chemical reactivity. So the reactivity of an element depends upon its tendency to lose or gain electrons. As we know, metals shows their reactivity by losing the electrons and non-metal shows their reactivity by gaining the electron to form bond, right? Here talking about, for example, among the alkali metals, that means the metals of group first, cesium is the most reactive. Francium is not considered as the element of group first because it is very unstable and radioactive. That's why we can say that cesium is most reactive, that shows reactivity, and it is a metal, right? Now on the other hand, the reactivity of non-metal decreases down the group. For example, among halogens, group 17, fluorine is the most reactive while the iodine is the least reactive, right? Now, moving ahead, the alkali metals, that is the metals of group first, are good reducing agent because they are very electropositive because they have the tendency to lose their one electron in the outermost shell very fast. While the halogens serve as a good oxidizing agent because they readily pick up the electron and reduce themselves. That's why they act as a oxidizing agent while the alkali metals act as a reducing agent, right? Now talking about what is the nature of these oxides. So metal generally form the basic oxide or sometimes the amphoteric oxide, right? You can see here sodium is a metal when it forms oxide, and when this oxide is reacted with water it forms a strong base or a alkali base, that is NaOH, that is sodium hydroxide, that is a alkali, that means water soluble base. Now talking about non-metals. So non-metals forms the acidic oxides like carbon dioxide, sulfur trioxide. Then we have nitrogen pentoxide. These are some acidic oxide because when these oxides of non-metal are treated with water, they form acids. For example, carbon dioxide on reaction with water forms the carbonic acid. Here, some metal oxides, as I mentioned earlier, are amphoteric in nature. That means they show both acidic as well as basic properties. For example, zinc oxide, right? So, zinc when reacted with an acid, that is HCl, hydrochloric acid, it forms salt, that is zinc chloride, and water. That means it is a neutralization reaction. When a base reacts with the acid, forms salt and water. But when this zinc oxide again reacted with a strong base, that is NaOH, sodium hydroxide, it again forms the salt, that is sodium zincate, Na2ZnO2, and water here. So this oxide is showing basic characteristic in the first reaction and acidic characteristic in the second reaction. That's why it is called the amphoteric oxide. Here the carbon monoxide, nitric oxide, nitrous oxide, and water are some important neutral oxide. That means they do not show acidic as well as basic properties, and neutral oxides do not have both the properties of acid or base. Right, now moving ahead, the metallic character decreases from left to right in a period, we know that, and the basic nature of oxide gradually decreases and the acidic nature gradually increases. You can see here, if we are moving from left to right in a period, right, so the oxide forms of the element are basic, then become amphoteric, that means both acidic as well as basic, for example aluminium, right, but it starts turning acidic as we move towards the right of a period because due to increase in the non-metallic character, right. Here the bond between the oxygen and the element will also be changed because here in the starting of the period the bond is electrovalent, or we can say that the ionic bond, but as the oxides become acidic the bond also changes due to the non-metallic character because non-metal forms covalent bonds, right. So here the bond changes from ionic to covalent. You can see here the trend in the change of the reaction. Now this is the summarized diagram of all the properties that we have studied. So this is the periodic table, this is the left portion, and this is the right portion. So we can see that the electron affinity, ionization energy, electronegativity, these three increases when we move from left to right, and the non-metallic character also increases when we move left to right, you can see here, but the metallic character decreases from left to right. The metallic character increases when we are moving opposite, that is right to left. Also the electronegativity decreases down the group and increases up the group. That's why fluorine, for example, have 4 electronegativity, and the lower members of the group have lower electronegativity than the fluorine, that is the first member of the group. So this is the flow chart of your all the properties. So I hope this topic is now clear to you. Thank you.